Past research and our own research has established that people are generally quite bad at estimating how much they're using their smartphone for on a daily basis. So, how do you conduct research into smartphone usage if you can't rely on that? We considered a number of options, but the one we stuck with was we wanted to build an app. Now, this app would have to do a number of things. The app would have to do respective logging if possible, so it would establish how people had previously been using their phone before they installed the app. It would it would monitor how people were using their app as the app was installed, running in the background. It will also provide context for the data that was established. Introducing Usage Logger. Usage Logger has three components: customization website, an app, and a decryption website. I'll go through all of them now. So this is Usage Logger customization website. It allows to customize how the app works, of which you get a detailed instruction all in the instructions here. But I'm gonna provide a demo now, and we're gonna build our own app, and we'll see how that goes. So here we have the different sources of data. This is contextual data, past usage, and prospective logging. Let's start with past usage. So this will be every aspect of smartphone usage for the past 5 days. This will include what the person used their phone for, what the person used, so when the screen was on, when the screen was off, what apps were used. It gives a millisecond accuracy for these kind of events for the past 5 days. Yeah, so that's pretty self-explanatory. We'll stick that on for 5. Then we're going to go prospective logging. This is data that is being collected in the background. So when the app's running, it's actively collecting whatever data that we want. We have a lot more sort of ability to customize this. So we can get screen usage, so when the screen's off and on, app usage, which apps are being used at what point, notifications, which apps are sending notifications and when are they being deleted, and then change in installed apps. So if any apps get installed or uninstalled, then we identify which app was removed or added. So finally, let's talk about contextual data. This is contextual data provides more meaning for the other two sources of the apps. So if a person spends their time on 3 different apps, it's interesting to know whether they only have like a couple apps installed on their phone, if they've got a huge number of apps, but still only use these 3. So that's what installed apps gets you. The permissions requests, these are when the apps request access to restricted sort of data or restricted processes. This can be anything from accessing the internet to reading call logs, listening into calls, or extreme kind of permissions. So we're just going to put that on, and then response to permission request. So for a number of these different permissions, it won't be for every one, but for the more sensitive sort of permissions, the user of the smartphone is required to actively give their permission for a request. So if I want to send text messages through someone's phone, I have to get the permission from the user that I can do that. So this provides a better understanding of privacy that the participant has. So now we can customize the order. There's a few little things that you might think about when choosing this. So right now it's past usage, prospective usage, and then contextual. So it would look 5 days in the past, then it would start monitoring in the background. What is the participant doing? And then retrieve these aspects about the phone. This would get us most data coverage looking 5 days in the past at how the participants use their phone, but we can then see how does the participant use their phone when they know they're being monitored. This would be an interesting study into demand characteristics. Alternatively, if we wanted to do 5 days worth of logging and then got the same data set, we could have more confidence in the data that we retrieved. So that's an interesting thing. And the contextual, that could go at the beginning or end. It wouldn't really make sense to put in the middle. So we're going to go with this. So when we're all done, we just click finished. A QR code is generated and you can save that there, which I am going to do now. So this is the actual app. I'm going to be running it in an emulator on my computer. So first off, we get these notification alert dialog box, if you want to be technical, pops up, is being recorded. This goes somewhere in the way of ensuring that the participant is informed. So the app needs the camera permission in order to scan the QR code. We wouldn't need this. We don't need this now for the emulator, but we're gonna get it just to sort of go through the steps. So we're gonna go deny just to show you, and the pop-up about why we need this is given. We go okay. Now you allow. Next step is to scan the QR code. So just to show you again, at any point of what the participant's confused about, they can just go next step, and information about what happens next will come up. So now we would scan the QR code, but what's going to happen is the data is just going to get put straight through. So it was as if I, in the background, scanned the QR code. So yeah. So after we've scanned the QR code, we get an alert that this app is intended for scientific research. Please do not use it for any other purpose. But now we get a detailed information about what the app is going to do. So this was all determined in the customization website, which you saw a second ago. So the types of data, apps installed, permissions, how you've previously responded to the app's request for permissions, what previously have you used your phone for, blah, blah, blah. So there's all those different types of data that we're going to collect. If we press OK, then it's going to go. Data security, blah, blah, blah. We're using encryption and we'll provide you a password. So here's the permissions required. Here's the password, which you can go back and access at any point. We've had a difficulty with ensuring both making this as simple to use for users, but also making it secure. So if we were to use allow the participant to copy and paste this would then go onto the clipboard of the Android phone. Problem is, those are notoriously insecure. Problem we have had now to do it this way is that we have the participant needs to copy this down. But there's an issue with capitalization of I or the pipe or other kind of ambiguous characters, So it's better just to take a picture of what something is, and then take a picture of the password from your participant and just have that. Regularly, they struggle to copy it down right. We're just going to go through the permissions. You need to give the app permission to access the notifications. So what's usually really interesting is you'll see all the different apps that are accessing these sort of secretive permissions. Here's the other one. This is usage access, so it allows you to see what other apps are running and stuff like that, and what have previously been run in the background. Okay, all essential permissions. and I click this, data is going to start collecting. So this is the context that we're getting from the thing. Now we see this notification come up here, currently collecting data in the background. This represents the passive data collection that's going to be going on. So if I go out of this, well, I'm going to close it. The data collection only starts working when the screen's turned off and then is turned back on again. So now we will be logging everything that the app does. So we'll go and we'll quickly jump into Smart CBT, which is another app I built. And then I've decided that I hate Smart CBT, so we're going to uninstall it, which also lets us test stat functionality, just by coincidence. Let's see, then we're going to go into play music. God, I wonder if there's any music on here. Probably not. And finally, we're going to go into calculator. So, great. So that gives us some data for what to look at. Going to go back into usage logger now. So the next step, that was retrieving all the data retrospectively about what's happened. And the only remaining step is to send an email. Do you wish to send the data at this point? So then you go, okay. Just once with whichever email. And if this really works, yay. I was only worried about the emulator jumping into my email. And it's, simple as data. This is all encrypted and protected. So as you'll see, this got 9 gigabytes back because we only use kilobytes back from usage. So I haven't used this emulator for very long. We got a huge amount of data from the context, all the permissionless requests by the app and this kind of thing. And prospectively, we got a little bit of data. So that, and then we'll send that off. Okay, great. This is the, I'm just going to go through the data that we collected from the Android app. So this was the password we had. The issue we had was, is this an L, is this an I, is this a pipe? So there's just no way around that. You just got to sort of work that out and try every option. You're given enough attempts to figure it out. So first off, this is the usage. This will be this is previously what the app was used for over the past 24 hours. So a lot of this will be a little bizarre because it's from data from an emulator, which is not running as efficiently as a proper Android phone, especially not a new one. What we get is the Unix timestamp to the millisecond of when an event occurred. Now these events are coded. 5, I think, is a standard. Is a user interaction or standard or bucket change. I can't remember. I think 1 is on, 2 is off. All of this will be established when you use the decryptor, I'm pretty sure. If not, there's code that we've got and which tells you the significance of each one of these. When an app doesn't have a sort of established name, it reverts to we return this, which is the package name, and this can be used in order to figure out what kind of app is being utilized. If you go to the Google Play Store and enter it into the hyperlink, it'll go directly to the package with the same name. Yeah. So onto context. So this is what's the particular app. the permission asked, so YouTube asks to read context. I said false. Get accounts, I said false. Let's go to something other than YouTube. So here's usage logger. So I gave access to the camera permission. The foreground service, interestingly, was false. At that point, you don't. That's interesting. But do we get the notification? Usage stats, foreground. We don't get the notification permission. That didn't enter into the request. So those are special permissions, so those don't usually get picked up. And finally, we'll go to the perspective viewer. So this will be a Unix timestamp, to the millisecond associated with what happened. So there was a note posted by usage logger. This was to say that I've started recording. The Android system posted a note. The screen was turned off. The user was then the screen was turned on, so the user was present. User present is usually associated with the entering of a password, but because a password was not required on the emulator, it came up here. Then we went into the Pixel launcher, so that was the home screen. So a note was posted that I didn't notice. We did go on to Smart CBT, but that wasn't. So the emulator hasn't been running so well, so it didn't pick up that we actually accessed the Smart CBT, and it did recognize that we went to Google Play Music. Maybe it's just for sort of longer durations that you're in apps. And it didn't recognize that we went into the calculator. Yeah, so that's a bit of a shame. Okay, so what you discover if you've got all these PDFs is that getting them out of PDF form can be quite difficult, especially if we go back to context, where you have all these different kind of different rows. So if you wanted to take, like, you wanted to make a CSV and you did every row, you'd have to go through usage logger, Android permissions, package stats, false. So you would get, it would be 2 rows here with 3 columns, and then something confusing would happen. It wouldn't be very useful. And there's a bunch of R and Python packages that claim they'd be sort of good at this, but they're not really. So I kind of developed my own system for more accurately getting the sort of issues out. So we will, so this decrypts the encrypted files. So we can go in, I will get the context PDF because this is the most tricky one. There, that took a second to read it all. You have to insert the password and then press submit. We iterate through all the pages, scanning all the details, and then we produce a CSV when we get to the last one. So hopefully, yep, so we get a much better, very nicely we've handled all the different, the tricky format of the PDF and put it into this nice format. We haven't named the columns because you can do the same on this website. Go, and then we will read the usage logger, insert the password, and then we get that. So we have this. Sorry, so this doesn't, because we wanted to be able to decrypt all 3 different types of data. We don't have something that tells you what the type of events are, but this is in the Python and the R code that we supplied. Okay, so we're gonna go through the analysis. This is gonna have this is gonna be in Python. So yeah,
here's importing the modules, so the different stuff that we're going to need. Here is what Java would call a switch, where you supply a number and return a sort of value. This is how we're going to convert the events that Android pass usage does. This is where you convert Android pass usage events into something of significance. So event 0, nothing happened. Event 1, an app moved to a foreground. Event 2, moved to the background. 3, it was the end of the day. Blah blah blah. Now we have some sort of code, a little bit of code that we've done ourselves. So there's a number of events that we've deemed important. Other ones will just be sort of removed. And this is number 1, app moved to the foreground, moved to the background. The user interacted with the app. The device shut down and the device started up. Active events, when is the phone actually being active, is 1 and 7. And we've also put in an idea about how, an issue about a value to say how long is too long to use a app without guessing that it's that the person just left their phone on. So if the person doesn't swap between an app or is using one app solidly for 2 hours without taking a second break, we're guessing that they're not actually there and that they just left their phone on. So if an app is used for 2 hours without any interruption at all, it is removed during the cleaning. So this will go through all the sort of cleaning. I can't remember how each of it sort of functions now. This was done a while ago, but the sort of cleaning will occur. I'll go through. So we'll remove all events which are not deemed important. Remove events which are sort of unnecessary, like the move to background event will be sort of just get in the way of the analysis. Sometimes, and those will be removed in those instances. Remove all events which are duplicated. So let's say we had app started, app stopped, app started, and it was for a fraction of a second. Then it'll be removed. Remove all background events which lasted only a second. So those are two similar things. So yeah, that's the cleaning. Then we have importing the data, assigning the columns, assigning some more variables. So we're just going to run that now. And this is the data frame that we have. The end, what we get is the Unix timestamp. So what was the time? Which app was involved, what was the event, what does that event actually mean, and how long did that go on for. So for settings was in the start, and it was Android setups, then it was back to settings for 32 seconds, then it was Pixel Launcher, and then we went into Smart CBT. This is something that the emulator sort of come up on its own. It's had a bit of a spasm before because none of this actually happened. I didn't turn on the app during this time, so we get some weird data. I'll show you. I'll go through that later because I didn't actually use that app at all. So here we're going to establish date and time. So today the phone was used for a duration of 2 hours and 2 hours 0.86999. That's not in seconds, obviously. So establish top app used. So there was this weird thing that sort of came up, is that the Smart CBT app was used. Unfortunately, I didn't actually use that at all. There's been some sort of issue with how the data collected from the emulator. Um, so we could import the context here and use kind of stuff. Use stuff here to get analytics on types of apps, like types of apps that are using location to monitor person, so we could see how long that person's been, their location has been monitored for in some vague sense. So here we're starting with a visualization. This is a barcode for, I'm just going to start running along the other one because it takes a while to run. I'm not really sure why. I think this could have been done more efficiently. I coded this a while ago when I wasn't so familiar with Python. So it spits out this visualization. Because it's an emulator, there's no, I don't usually stop and start it. And there was something weird at the beginning of this because I was working on this not from 6 in the morning, but from about 9 to 10. So two things went wrong here. It said that I was working an hour earlier than I was, which was weird because I've checked the time on the emulator. So that was weird. And there's no reason that should happen. But also, as we can see here, this is all the different apps. So we've got the Pixel Launcher, which is in black. So that's the home screen, which is hardly used. Then the Smart CPT is in red. Git Explorer is in green. Gmail is in blue. So you can see how long I was trying to set up my own email on the emulator. But basically, I started using the app with Git Explorer. So all of this red stuff, please ignore. I don't know. And also this was around 9 o'clock. That's when I started working. So the results are a little weird when utilizing the emulator, but this isn't so bad with it. We haven't had these errors come up when we're using real phones. So yeah, that's the sort of basic analysis.